Now it's my pleasure for the last presentation tonight. Just to get you informed, who attended my presentation 2 years ago with a demonstration on RF dump? Who was in the audience? Who is using RF dump? Oh, only a few. So let's get started. Our agenda for tonight is what is RFID, how to exploit and attack RFID systems. We have done some stuff like Melanie does with attacks against the middleware. We added a new feature to RF dump. It's called reader emulation or soft tags. Some words about the unexpected risks in the middleware and some new ways to exploit the system. But our main focus for tonight will be encrypted RFID tags, like the ISO 14443 tags. So a short overview, what is RFID? It stands for radio frequency identification, and it's in fact wireless transmission of information between transponders and readers without visibility, and that's it. And most of the times we have bidirectional transfers, so it's able to read and write. Even if they only call it readers, the most of them can write to the tags as well. And we have a transponder or tag, and this can be attached, embedded, or implanted. And the main feature of RFID is the automatic correlation between object and saved data. This can be a garage door or something like this, a human in a bar or a passport or something like this. So in most times there are a lot of generic terms, and RFID is often used as a generic term for complete infrastructures. For example, a transponder, also known as RFID chip, tag, label, wireless label, or simple chip. We have the reader, we have some middleware. This connects the reader with the server. Most of the times we have communication infrastructure, and all this stuff is integrated with server farms, data warehouses, services, and supporting systems. Let's give you a short overview. For our work, we are working on standardized RFID, like ISO 14443 A and B, like mid-range, short range, and long range, and I've divided the RFID classes into the reading distance. There's the 1356 megahertz and the 125 to 146. This frequency is quite popular if you need to go deep into the material, like tagging humans or animals. The 13 megahertz is popular for Vincity cards, for access control, passports, and 15693 is most used for normal memory tags used in the supply chain or stuff like that. And what different types of transponders do exist? And there are different types of transponders. Some of them are only transmitting a unique ID, something like a serial number. They are only passive, that means they don't need a battery to get powered. They are useful for identification, tracking, like the fast track system, and most of them are only using clear text communication. Then we have transponders that actually act as a data storage. You can compare this type of transponders like USB sticks, pretty small USB sticks. Most of them are passive, some of them are active. Electronic product code transponders are an example for this. We have the smart labels. Most of them are also using, most time, clear text communication, and some of them are using encrypted communication. And we have the smart card interfaces. Most of them are active, some passive. Best example is the ICAO MRTD, machine readable travel document. It's biometric passport. And some access control systems like the MyFair Deathfire. The features of this tag is encryption, authentication, and encrypted communication. And this will be our main topic for tonight. Some generic attacks to RFID. First, you can sniffing the communication between the transponder and the reader. So you can counterfeiting the communication. You can try to obtain the user ID the user data or the metadata. You can do basic attacks with this type of attack, like attacks on structures, the data structure that's saved on the tag directly. You can do a replay attack to fool an access control system. Then we can try to counterfeit the identity of the reader and trying to unauthorized writing to the text, like changing the UID via manipulation of the administrative block. We are able to declare false identity. And unfortunately, the UID must be readable in clear text because the whole system, the whole anti-collision depends on this. You can do a manipulation on product groups and prices, for instance. We have presented this 2 years ago. And you can try to manipulate the data stored on the transponder, like the manipulation of data, the manipulation of data, metadata, like swapping objects or logical duplication of objects. So if you go into the store, if you want to buy a new computer, you just swap a pair of spearmint or of bubblegum, swap the objects, and now you can buy a new box with an automated checkout at the price of a bubblegum. There are some other generic attacks like the deactivation of the transponder. This disables the traceability of objects and the visibility of objects, and you can do it with specific attacks, with your famous home appliances like microwaves. And you can attack the structures in the middleware, the backends, and the manipulation of the structures, like injecting malware into backends and middleware systems. For instance, database worms. You can try to use this injection for manipulation of backend systems, and you can try to run a DOS attack against the infrastructure. We have seen it, the talk before, jamming of RFID frequencies. Some of these attacks are known as anti-collision attacks, this type of theoretical paper from Avi Jules from RSA. In fact, the block attack was never implemented and never demonstrated. It was only an academic paper on it. You can buy an out-of-the-box police jammer. So these are available over internet or buy it on eBay. And these types of jammers are used to block frequencies where suspects can communicate with their colleagues or doing communication or opening the garage to escape. So the police has pretty handy boxes, and with one finger snip with this box they can block your GSM frequency, they can block your mobile phone frequency, the frequency for your or for your free wireless phone, and as well for RFID frequencies. And all these attacks preventing reading of the text. It's a simple denial of service against RFID systems. But imagine if someone brings a jammer or something like this into a company or into a plant that's organizing their complete production process with this type of attacks. So you can shut down production, sales, or even block someone to get into the data center. 2 years ago, as we presented RFDump, I got a lot of quotes. Oh, okay, but all the tags are unencrypted. The normal EPC is using standard unencrypted communication. The data is not encrypted on top of the RFID tag. And the spokesman from the RFID lobby is telling us, oh, Lukas, is not true. We will use encrypted tags. We will secure it, and with encryption, everything will work fine. So no attacker has a chance to change anything on an RFID tag. So we did some research on MyFair. MyFair is the most used RFID transponders featuring encryption. This is a technology. It's owned by Philips Austria. They actually bought this company. And the technology is based on ISO 14443, like passports or some different other tags. And they're operated on the 13.56 megahertz frequency. We have 2 different families of MyFair tags. The MyFair standard family is operating a priority high-level protocol. and proprietary security protocols for unification and ciphering. We haven't spent so much time on this proprietary stuff because it will be changed to standardized stuff, but I'm pretty sure this proprietary ciphering, if they are not going to release the cipher algorithm so someone can do a crypto analysis, will be some less or more type of storing with a standard secret like all other proprietary ciphers. There are also MyFair Ultralight, the same tech without any encryption. And we have the MyFair Pro, Pro X or SmartMX tech. This family of techs is fully compliant to the ISO 14443 standard. And there are different types of techs offering memory protection. And each sector, each memory block of this tech is protected with two different keys, the A and the B key. And each sector of the text can be protected with one of these keys. First, we have written a small Perl tool, a small Perl script, trying to make a brute force attack and trying to figure out how long it would take to break it with a brute force. In the worst case, we end up with 22,000 years because you need 25 milliseconds per key. You must set answer to reset back to the key, and it will not work that way. The second chance was, oh, what's happened if we just clustering it and run 1,000 RFID readers? So these techs are quite popular in cafeterias at universities and stuff like that. So it should be not a problem. They have all one shared secret, one shared key. To get 1,000 of these keys, every student runs an RFID reader, but we have still 226 years. So let's find a different way to get this information. Unfortunately, Philips put all information under NDA. And you know, if you are doing security research, NDAs are not good. For instance, if I would sign an NDA and give a presentation like this, they can sue me. So we are not at all interested to sign any type of NDA. Instead, we get some software that's really available, and we need some point to start. So we run the Unix tool strings on it. You know what strings is doing? Yeah. So actually it's extracting from executable binaries all zero-terminated strings. And after we got some strings, we start some Google hacking and looking what are the results with strings that could fit as a sector key. And Google helps a lot. It seems like Google Desktop Search is very popular at smart card developers' PCs. Look at the results. So without signing NDA, we got all necessary information. We got keys, we got data sheets, we got descriptions, and even sample applications. So we found the following default keys. These are the keys where the new cards could be shipped with. And we found about 60 keys from example applications. And also there's one specific key that turns off all encryption features. Also we found a nice document. It calls MAT, and it is really MAT. It calls MyFair Application Directory. And this helps if you're doing some investigation and reverse engineering on this stuff, because Philips wants to organize the multiple type of use for their crypto RFID chips. So they introduced a directory where each developer can sign up and write into a sector what type of application and what type of data layout he is using for his specific MyFair application. So in this Google data sheets and documentations we found a huge amount of examples. So we found examples including different keys, different tech memory layouts, as well as data structures for ticketing, access control, and online payment. And you know developers are really lazy. So we checked a couple of these cards and we succeeded with more than 75% use the default keys. So something like, oh, it's compiled, let's ship it. And even I cannot believe that the programmers don't understand anything at all. So they are not only using the example layouts from the data sheet, they are also using the keys. By the way, are smart card developers here in this room? No one. You know, how can we bring this notice to a smart card developer? It's pretty good if you understand what you are doing and not only putting the example layouts from the vendor and, oh, it runs, okay, let's ship it. So we figured out directory attacks are the best way to get into encrypted RFID. Attacks are possible with default and example keys. The new RFDump version will have a huge dictionary, and we are right now working on, you know John the Ripper? With features like John. So you can mutate and apply rules to the dictionary we found. So it's much easier to brute force or to do a smart brute force attack to the RFID tag. And we found some security flaw in the general design. I've never seen something like a logout or false login counter. So you can try unlimit twice, and they're also missing a delay for a false key. Just does not exist. Okay, and this part I want to give you a short demonstration. I run this wonderful operating system in a VMware here. This is a new version of RFDump. It's actually on the CVS. We add support for the MyFair stuff. I have here a couple of cards like Cafeteria from the University of Brunswick, Cafeteria from the University of Berlin, and some examples. And we changed RFDump a little bit. So now you can start a scan and it will read the tag completely. It's now scanning for a tag and starts reading the page. You can stop it. And you got the famous known version of RFDump with a pretty nice ASCII and hex editor. So if you know the layout, you can just change the amount and doing stuff like this. And we added support for much more readers and much more frequencies. And we introduced this nice new feature, crack key A and crack key B. So with crack key A, we are running a brute force or a smart brute force attack like presented on the card, and it will take a couple of hours to break the sector keys to get on the content we are all interested in. And we got the application layout. We know what byte has to stand at what position on my sector, what byte is presenting my day for validity for my ski pass or my amount on my cafeteria card or something like this, or even my access level for my data center. And most of the times, if you're pretty smart, you get 2 or 3 of these cards, and you can look and you know your access level for your colleague, your access level, and try to diff them and figure out how the privileges are organized inside your organization. Now let's come to the second part of my talk. Just let's attack the backend. Now we got the RFID tag, we got access to the also encrypted sectors. Now we have something like normal storage. And we can use this storage to transport malware, SQL injections, buffer overruns and stuff like that directly into the backend. We have to know if a tag is read-only, and we need to change something on the tag. We just need to clone it. This can be done with ifdump. So you can go and you can load and save the content into a XML file, and with help of this XML file it contains the payload of the RFID tag. You can load this file into an RFID emulator and change any sector, like the unique ID and stuff like that. And the new version of ifdump can emulate the complete structure. So it can emulate the payload, the administrative block like the unique ID that's normally not changeable in this way, and it also emulates the reader. So if you want to break in the access control system, you just rip off the reader and put your serial, it's most of the times the RS 448 or something like serial TTL level connection, and you can just connect it with an adapter to your notebook and emulate everything. As well, you can load this saved value and just dump it back into an empty new RFID tag. So we are able to deal as well with read-only RFID. So just write the manipulated data into an empty one. We found out that some of the really clever smart card guys check some of the tags. They are just mirroring the unique ID into the user data fields. And if the block is encrypted, once again, the sector key must be broken like presented. Now let's have a look to the new, pretty new world, the supply chain. We have a central data warehouse. At production time, the product gets registered at the data warehouse. They are tracking the distribution. They have a pretty new feature. It's called lifecycle management. Something like, oh, your Rolex needs a new battery. Please come to the store. At the point of sales, the data could be correlated with the customer data like your credit card, your customer record, your loyalty card and stuff like that. And they're able to operate customer care. This means all the systems must be connected in a network, must communicate within and must have some type of relations. So what's possible with this brave new world? We can take some of this malware. The most systems have a tool, it's called Event Manager. So if an RFID tag gets scanned, it's coming to the Event Manager, going to the information server or the middleware, and ended in your ERP or CRP system and in your backends. One problem with this design is they just want to make the tags as cheap as possible. So they just ignored some functions on some RFID tags that give you an information if you read up to the end of the RFID tag. Instead, what's happened? The page just gets flipped and you get a multiplier of the page beginning with this address. So you can utilize this feature. Now we have unlimited space on the tag. So you can use ifdump and the tag database. And we need to use this tag database to avoid reading over the boundary. Let's have a look to this. Oops. And with this tech database, it's necessary to know the actual size of the RFID tag. If you don't know how many memory sizes or how many memory pages you have and the memory size of the tag, the most readers will just read above them, and the most tags gives you a multiply of the original content back. I don't know, it's a bug or a feature. So normally the reading is event driven, like a barcode. The barcode starts reading, you get normally an introducing sequence and an end of field sequence. And you know, all these EPC guys are only thinking in barcodes. So why spend more into one of these features that give you an error back if you're reading after the end of the tag? We are just implementing an end of field. So, and like the most new systems, the input is always unchecked in all implementations we have seen. So this is an example. We have here RFID tag with a C structure, and we have this nice feature with a C end of string. So imagine what's possible. Any ideas? Yes, to remove the end of string. And if you remove it, we got unlimited memory. So if the input is event driven and we got unlimited memory, what's happened? You get a buffer overrun, and that's it. By the way, I killed my office physical intrusion detection system by this way, because they are using a pretty cheap TMS microcontroller, and after I've killed this and the service company was unable to repair it, I just disassembled it and found out they are using a TMS TI controller, and this controller is not dividing code pages and memory pages. So I got an access card for enabling or disabling the alarm, and I cloned this card, removed something, and unfortunately it gives the error like error on that, and that was it. So I called the vendor, oh, we have a problem. Our alarm system does not work anymore. I tried to deactivate this, I got the error on that, no alarm sounds, and all doors are open right now. Oh, we don't know this error. Probably something must get wrong. And I found out I just overwritten the actually programming of this microcontroller, and the result was I just destroyed the programming, no alarm sounds, and the door opens. Unfortunately, the system was tested and approved by the insurance company, and the insurance company telling you, oh, if you buy this specific system, your insurance will go down because it will raise your level of security. Instead, you have the ultimate tool just as door opener. And I don't know what's going on, because the service company came and exchanged the microcontroller, and I just want to test the cleverness. So I just put, after the guy from the company came, my tag in front, and that was it. And he told me, oh, we have a problem with the series. It must be something like your electrical power or something like this. I'm not sure that pretty even don't know that they're using RFID. They're using some type of transponders. Okay, so now there are some patterns. They are now starting to put direct XML into the RFID tags. Or we can do the same like with C structure. Just put opening tags, and at some level it will crash. The next idea that's coming to RFDump is soft tags. So the readers are pretty expensive, and no one is interested just to use a reader. So if some of your hardware guys is interested, you can use a Atmel or a small microcontroller with an interface, and this can act as a battery-powered RFID tag and reader. So we can emulate the whole system and put any testing data into the backend or the middleware. Our version can read the backups, the XML files from RFDump, and we are able to manipulate everything because we have the full control over the complete system. Okay. Now, is anybody interested to come to the podium with some of his favorite RFID ISO tags like access control? We can have a nice demonstration. No one? Okay, we can shift to the question hour. Oh, we have one. Okay, I'm not sure is it ISO, so let's check it. No, it's not 14443. Yes?
This is an RFID tag they're using in the mystery box challenge.
Okay.
I'm not sure what that is.
Okay, thank you. Okay. Okay. So I cannot get it. It's probably not in my tag database, but I have a backup tool with me. Let's check the second one. No, it's not 14443. Perhaps the range is not. I cannot select it. It looks like. Yeah. But if it's a TI chip, it's probably. Oh, we got it. You have to put it on the opposite side. The range is not really huge. Okay. Let's try it with RFDump once more. And look what's on it. By the way, as soon as I got reliable internet back, you can go to our site and download this version with a VMware player. So there's no longer a need to install Linux on your box and to handle and hassle with this stuff. You can just use VMware and run it on a CD or doing a live demonstration with this. We're using the ACG reader. And yes, it's unsecure. I'm using an auto login as a root, and I'm just starting RFDump, so please don't complain about. Okay. Now I have to avoid this trash in my queue. Okay, we got it. Now I have to hold it directly under. It's hard to get. Oh, we got an unexpected page size. You know the page size of this? Okay. No, I got the ID. Yeah. I need to investigate something about more of the page size. Okay, so I need to apply for American Express card to get unlimited credit. Okay, thank you. Let's have a look to this access card, and then we can release you from your pain. No, it's not. If you come to the podium after this, I have a couple of different RFID readers with me, so we can check it out. Okay, let's start with the question session. First question. There's a microphone in the middle. It would help a lot. No questions? We have support for ACG reader. This is standard Philips chip, and the nice feature for the ACG readers is modems with the AT command set at the Aegis command set. So you can communicate with these readers with a ASCII command set and can just open something like a minicom or terminal program to punch in commands and try something out if you are in doubt. The most of these RFID readers are designed by the same stupid guys. They are designing smart cards. So you have, you have something like, you know what nibbling is? Bit nibbling and stupid binary commands to send to them. And ACG got so much pressure from the smart card guys, they are now supporting 2 versions of this. So you can switch into a complete brain damaged binary protocol and still use a nice ASCII protocol. And if you're interested to get one of this ACG stuff, you can now order it over the RF dump page. We don't make any money with it. You can just check the price, and we do also ship to the US like somewhere else. As well, we have an open API, so if you want to put in your reader into RF dump, there's a C structure. You can put in what type of commands you are sending, what type of feedback you are getting via regular expression, and can use our reader API to put new readers into RF dump. Okay, next question, please.
I'm just curious, have you ever done any work with the military CAT card in their RFID system?
What type of card?
CAC, a CAC card, Common Access Card.
I
wish I had one to scan for you, but I don't. But,
the problem with all this US military stuff and proprietary US stuff is I feel not comfortable to checking one of these cards here in the podium at the Defcon. My lawyer told me what I can say in the US and what I should not say. And if some Fed is interested that we are going to do an audit on the software or something like this, we can organize something. But I'm not feeling comfortable to speak about. But I do know that NASA is using MyFair as access control. And this is one of the biggest customers.
So they were like, you want to come back for DEFCON 15, right? They were. I understand that, but have you been directly threatened then, or have you been directly threatened then, or you just prefer to kind of keep quiet?
I just want to avoid some situations.
That's cool. I appreciate that.
Yeah. The next question.
You mentioned that a lot of companies use the default key. When a company deploys in general, will they use a single fixed key, or will different RFID tags have different keys? Like for a single company's deployment of a given product?
Normally you have one shared key. So the reader needs to know the key to communicate with the company cards. And some of the companies are clever, they audit their solutions, they set up one key per card. And this is normally not possible. So most companies using one shared key with one fits all. And this shared key is responsible for all sectors that are used by the company. But the MIFARE standards allows you to put different sectors. So you can put up to 16 applications. Each application is using a different sector, and each application could be protected by his own key. So the application for ticketing does not interfere with the application for access control or for paying your cafeteria. This is the main idea behind this MIFARE application directory.
Thank you.
You were saying that maximum 16?
Yes, 16. Yes?
The reason MIFARE, every card will have a different key because they use uneasy virtualization.
No. Every card has a different unique ID. And this unique ID is used for authentication and for anti-collision. But the application that's run on top of the MIFARE is normally used one shared key for the complete sector. It is true that some MIFARE cards can use a DES, so they can use unique keys for the communication, and they can change the key for the communication and for the secure channel. But to access to the sectors, they have one shared key. Okay? So if you have some additional questions, feel free and just send me a short email. My email address is Lukas with K @freak with ph.de. Okay, and enjoy this evening.